My dear students, now let us try to understand one of the important topics of the chapter, electrolytic dissociation and ionization, and what is the difference between the two. Let us try to understand step by step. Electrolytic dissociation. Electrolytic dissociation is a process by which an electrolyte gets dissociated gets dissociated into its ions, that is constituent ions, cations and anions, either in aqueous solution state or in molten state Okay, what does this mean? Let us take the favorite electrolyte, my favorite electrolyte, NaCl. So Na plus Cl minus this is what an NaCl molecule NaCl molecule looks like. Okay, these are electric field lines which you are going to study in physics in higher classes. Okay, so these are electric field lines because these are electric charges, that is why they will emit electric field. Okay, so this is electric field lines, and this is how a molecule of NaCl looks like, and this is electrostatic force of attraction between the both. So with electrostatic force of attraction between these charges, they are close to each other, they held tightly. What happens? So the definition, very definition you look, is that they gets dissociated into ions either in the aqueous state or in the molten state. So let us take the first one, that is the aqueous state. What happens in the aqueous state? Aqueous state means NaCl gets dissolved into water. So when NaCl gets dissolved into water, yani you are dissolving NaCl to water, you know that water, the structure of water is like this, H2O. Okay, and due to the high electronegativity difference which I taught you in chapter 2, what happens? Water is a polar covalent compound. Why? So that is why it will have a slight negative charge, the oxygen atom, and the hydrogen atoms will have slight positive charge. And due to this polarity of the water molecule, these two hydrogen molecules will attract this Na plus, and this slight negatively charged oxygen will attract I told the opposite. This hydrogen positively charged hydrogen atoms will attract the chlorine, and this negatively charged oxygen will attract the sodium. And this is why the electrostatic force of attraction, that is the bond, gets broken and it gets dissociated into Na plus Cl minus. So due to the force of these slightly charged hydrogen atoms on chlorine and the slightly charged oxygen atom on sodium, the bond gets broken and it transformed into Na plus and Cl minus anions, and they becomes mobile, free to move, and that is why electricity passes through the electrolyte in the aqueous state. Okay, so this is how electrolytic dissociation takes place in the aqueous state. Now let us talk about molten state. What happens in the molten state? Because in molten state also electrolytic state is dissociation takes place. Let us take the same example, Na plus Cl minus. This will be the electric field lines. Okay, so Molten state means you are melting the solid form of the electrolyte, that is, you are increasing the temperature. So when you increase the temperature, you are giving an energy, you are providing an energy, that is heat energy, and that heat energy is enough. When it becomes enough to overcome this electrostatic force of attraction, that is also an energy, that is bond energy. Okay, the bond energy which is involved in bonding these two charges, that is known as bond energy. So what happens when you provide heat energy to that molecule and it is enough to melt it, to transform its state, that is it overcomes the bond energy, then what happens, the bond gets broken apart, and hence Na plus and Cl minus becomes free and they become mobile, they move freely, and that is why electricity starts to pass through the electrolyte in the molten state as well. This is what electrolytic dissociation means. Now in the next video we'll be studying about ionization and the difference between electrolytic dissociation and ionization.